Hey folks, welcome to my channel number pen. So there we have the problem on the screen. Find the derivative of the following: x equal to a cos cube t, comma y equals a sine cube t. So before we jump into solving this problem, I want to draw your attention to finding the derivative of problems of this type, right? So these in general are called parametric equations. And why are they called parametric equations? Because you have x expressed in terms of a parameter, and then you've got y also expressed in terms of a parameter, and the parameter here is t, and therefore y and x are connected through this common parameter t, right? And there are multiple ways of solving the problem, and it totally depends upon how the problem is, right? Or what the problem is. And one way you can solve this particular problem is elimination of the parameter. For example, you can eliminate t and express y in terms of x and then solve the problem if it's a very simple elimination. But otherwise, it's always better to do a simple dy by dx using the formula dy by dx equal to, and let me write it down, and we will use this particular formula to solve this problem in this video. So my dy by dt, so my dy by dx equals dy by dt divided by dx by dt, right? So like I mentioned earlier, in a parametric equation of this type, you have x represented in terms of t. So finding a dx by dt is not a challenge. And then you've got y also represented in the form of t, which means you've got dy by dt also available to you. I'm going to start off with dy by dt, right? So let me write down my y. My y is nothing but a sine cube t. So what is my dy by dt? I'm going to apply the chain rule here. A is a constant, so it remains as it is. Sine cube of t, I've got two functions. One is a cube function, which is my outer function, and then I have an inner function called sine. So I differentiate the outer function first with respect to the inner function, which means I use the formula dy dx of x to the power n equals n times x to the power n minus 1. And instead of x, I have my inner function here, which means I have 3a sine of 3 minus 1, which is nothing but sine square t, right? Sine square t. And it's not yet over because I have an inner function called sine. And I differentiate that, I get a cos t, right? So this is my dy by dt, step 1. And then my step 2, I write down my x, which is a cos cube t. So let's write down our x, and what we need is a dx by dt, right? So my dx by dt, again I apply the chain rule like what we did in the case of y. So I differentiate the outer function with respect to the inner function, which is cos t. My outer function is a cube function, so I use the formula d by dx of x to the power n equals n times x to the power n minus 1. So I get cos square t here. So let me write that down. Then I go ahead and, I'm sorry, this is no. I go ahead and differentiate my inner function, which is cos t. dy dt of cos t is nothing but minus of sine t, right? So there I have my dy by dt and dx by dt. I go back to the dy by dx expression that we initially wrote, and then I put back my dy by dt and dx by dt, right? So my dy by dt is 3a sine square t cos t, and then my dx by dt is minus 3a cos square t sine t. And yes, I can cancel out the cos t in the numerator, and the sine t in the denominator with the cos square t in the denominator and the sine square t in the numerator respectively. And my 3a also goes out, and remember folks, I have a negative sign, so I'm left with a minus. Let me write it like this: minus sine t by cos t post all my cancellations. Right, I hope you folks are with me. And I can further represent this as a minus tan t, right? And in these problems, it is okay to leave our final answer in terms of t, right? Especially those equations which are parametric in nature, like the one we have on our screen right now. So there we have the final answer: dy by dx equals minus tan t, right? Let me highlight it in pink. Yeah, so there we go. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.